Hello friends, welcome back to Simple Haskell. So for this one we are talking about WriterT, and in order to do that I figured that I would go out and find an example. And now this is a absolutely shameless plug for another idea I have, which is Simple Nix. And why it's a plug for Simple Nix is because as you can see, I've actually imported Stitch into my project here, and all it is just this effectively random GitHub repository I found. And so Nix has allowed me to import the source code very easily. It took me a better part of 5 minutes, and it's really easy to do if you know Nix. So yeah. And there's another tool that I do use, but anyways, the point of this video, back from the shameless plug, is to talk about the WriterT monad. And so Stitch is an example of how to use the WriterT monad. And what does Stitch do? And Stitch is a great example of the common way to use the WriterT monad. And it's definitely something I will be planning to use for my own projects. I plan on writing a effectively different type of, basically a lazy JavaScript compiler. And so I'm kind of seeing that this is actually, like, a WriterT is a great way to implement what I want to do. And yeah, but so how does Stitch use WriterT? Well, and what am I talking about when I'm talking about JavaScript and Stitch and all of these? So the explanation that I found was, well, actually this is the tab here. What are some good examples of where to use WriterT? And the most common uses is in building DSLs or domain-specific language. And this one here is a tiny CSS DSL. And so this allows you to write your CSS in Haskell and then output some CSS. And they do that through the different combinators. So yeah, let's look at how this works. So just even intuitively, this combinator looks like it takes a do block or a monad, which can be quite broad in terms of what can be inside of that monad. And I guess this probably lines up with these brackets is how this works. And then everything that is within this do block is going to go within inside of here. And what is this here? We look at H1, H1A, color. So interesting. And so I guess it's also kind of dynamic in what it can do. I was originally assuming that this was quite basic, but it looks like it is able to do some combination of stuff. Although I'm not sure why you'd want to do that. Why would I don't know. But anyways, let's look at this. Just again, some random thing I found, and I figured CSS is a good example because everyone here, I'm assuming, is aware of how CSS works. And so StitchT is just a little thin wrapper around the WriterT monad. And so what is the WriterT monad? I have that right here. And it is defined as this data type. So again, another new type, and wrapped with a function. And the inner monad is applied, or the inner monad wrapper applies to the end output of this run WriterT function, making the run WriterT a monadic function in sum m. And so basically this would allow you to, for example, transform this with IO. And so we have something like this. And even still, this doesn't really tell you how run WriterT works. I mean, really, what we're trying to do here again is we're going to have something like this. We're going to say main equals do, and we're going to say run WriterT, some WriterT expression. And I believe for run WriterT, we actually don't. I think when you actually run this, I know run WriterT, if you were to use this, would of course expect a, you know, some sort of input. But I believe, if I remember correctly, that you actually start WriterT without any input, and so it starts with empty. Although I'm not honestly sure. Oh yeah, I got run WriterT. So this is just well, actually, oh maybe okay. I want to check something here. UnWriterT. So it's called UnWriterT, which is another kind of paradigm you'll see. You know, like unwrap this kind of thing. I guess is why that sort of language paradigm exists, or paradigm, not paradigm, language custom, I believe. And so I think with if I recall correctly, with reader it was run WriterT, and then yeah. But I guess they wanted to call that UnWriterT so they could do this run WriterT. So let me just fix this quick, because that was an assumption. And again, like I was saying exactly, this does not take any starting value for W. And the reason for that is that it's just going to start with empty. And so that brings us to why we have this monoid instance. And so what's the point of this? And again, we will get back to Stitch. And I am jumping all over the place, but my goal here is to kind of dive into the theory a little bit and then get back to Stitch and see how we are using WriterT to build a DSL. And so this is this monad, or sorry, monoid, my bad, logic is kind of the core of why this is perfect for a DSL. And so the easiest, you know, connecting it back to our CSS example, you know, I guess the way that Stitch works is a little bit more dynamic, but, you know, we could even just have something as simple as each time that we want to do some writer, you know, we want to build a part of the DSL, we could just kind of write this DSL line by line. Like, for example, we could have a function which, you know, we could even have something as simple as, you know, this function here, which just writes a singular line of CSS, and it could be bound inside of h1, so that it's just going to end up doing h1 without this body here. I'm not sure how that... Oh, because of that. Interesting. Oh, okay. All of these have... So I guess, okay, how I read this now is... So I'm just learning this DSL for the first time. That I guess all of these would apply to... Okay, so on hover, does everything have a font? You know what, I'm not too sure how this did. I also don't know what this does. But yeah. Anyways, you know, a very simple example of how we could write this sort of idea of Stitch or a CSS DSL is just simply that we have, you know, a function which takes a identifier. So for example, it takes a class or an ID, and then takes a do block, which is just some number of lines in our writer monad. And so, like, the lines, where do the lines actually come from? And, well, they have to do with the monoid. And where is this monoid? This monoid is what we are writing to. So, for example, this monoid could be a list of lines. where we are just simply writing some amount of lines to this built up output. And so again, the output of the stitch T monad transformer is just going to be a CSS style sheet. And so, just to fully explain, CSS style sheet, you can think of it as just a number of lines. And so that's why we can use WriterT, which has a monoid inside of it that we are writing to build up a DSL like stitch T, or CSS DSL. And so that ties into, there's a function, this is the core function that we do here, and it's tell. So implicitly, somewhere in stitch, this is using tell, maybe in perhaps a dynamic way to make writing CSS a little easier. But if we had our simple DSL, we would say tell, and then this would be some line, and or some a list of lines that we want to tell to our WriterT, and that would add it to the output. And so ReaderT, for example, just to kind of give the relationships, ReaderT allows us to access our state at any time. So we have with ReaderT a starting state that we're giving to our function, and it cannot change. Whereas with Writer, we start with no state at all, and we are continually updating that state. But in the course of running our WriterT, there is actually no method to get that state. The only way in which we get this state is when we do either one of these two. Run WriterT, where we get back the last value in our monad. So again, we can do any sort of arbitrary WriterT actions in our monad, and let's say the last one is that we do pure 1, right? We just literally do pure 1 in our writer monad. Pure of 1, and then we have a bunch of tells. So we're going to say tell 1, tell 2, tell 3, and but actually this will not work because we need 1, 2, and 3 to be monoids, and so we could make a false monoid of just a regular int, but instead I'm going to use sum, the sum monoid, which we talked about in the video about monoids. And so now what I'm going to have is writer expression. This is going to, I believe, it would type inference to say, okay, so WriterT, oh, what the heck did I do there? That makes no sense. That would have been this one. But anyways, WriterT sum was the, yeah, sum, I'm going to say IO. I'm going to run this in the context of the IO monad, and then A is going to be an int. So from this type signature, I can deduce that I'm going to get returned, when I run WriterT, I know that this X that I'm going to get back is going to be of the type, which order was it? It was A, then W. It's going to be of the type int and sum, because I do pure 1, so that's the int, and I tell a sum, which is going to get added up. So every time I do this, this new monoid is going to get added to state. And I think, didn't I just see an example of this? Well, it's just literally calling. I think if we look at the type of tell, it will show. No, that's not very helpful. Writer, does that do it? We do see, so mappend is where we actually run our sort of core writer logic, the most important logic in the WriterT monad, which is where we take this new state that we have and we append it to the old state. And so, you know, in the context of lists, let's say we're building up a list. We have 1, 2, 5, and we append it to 6 to 10. We end up with that. In the case of sum1 and sum2, and we need to import data.monoid, we get sum3. So in this case, I'm going to get back where if I was to, you know, inspect the type of this or inspect the pattern of this, that's what I mean to say, I would see that it's a 1, and then I would see that it's it gets sum of 6. But yeah, and that's the bones of writer. It's a pretty neat thing, and so that's why it's useful for DSLs, because, you know, really any sort of file that we could build up is just a set of lines or just a list of lines, and so it's very easy to see how we could build, you know, how we can model a list of lines as a monoid, and therefore iteratively building that list of lines as the WriterT monad. And so yeah, this is how we use it. Let's look at the types now that I have them imported. I believe I have them imported. So this takes a selector, a stitch T. Okay, so a selector and basically a monadic set of actions, and then it's going to return, well, itself as a monadic set of actions or a monadic expression, which makes sense. This would be our monadic set of actions. And so I guess what's happening here is that everything inside of here applies to, I guess this would apply to body in H1. Does that make sense? Body in H1 is color 444. That makes sense. A, what happens here? A has a color of 448. And I believe, I wonder what happens is that it looks like this this would not override this color, but only work for A. And so I believe if there's an overlap between attributes for this A, then, or for, you know, H1 and color, like how does H1 rectify color and color? I believe it just takes whatever the outermost one would be, but I'm not sure how they control that. Again, this is not a DSL I use. I don't see why I would want a DSL for CSS, and unfortunately my DSL for JavaScript is still in progress. But yeah, and this is just, so I guess this is just a DSL for how to build CSS using nesting of the monads. What does this do? Font. I'm curious. Oh, I guess, okay, this looks like a operator which combines font and family with a dash, and then font size. So font specific attributes. Cool. And it looks like this, I imagine these are the only two core functions that we have here. Is basically here's a selector and a list of attributes. The writer monad, or the I guess stitch T monad, which has a WriterT monad inside of it, would handle conflicts, and yeah. So that's how WriterT works, and an example of it. I hope you enjoyed this video. Please let me know your thoughts on this, and stay tuned for State T, which is basically a WriterT and a ReaderT. and I use it. I actually, while doing some research for this video, used it to solve a problem that I was having with my web scraping, and brought it down from a crazy inefficient, inefficient program to one which is very, well, it works in O of n. I don't even know what it would have been before. It would have been exponential. So yeah, StateT is awesome. So stay tuned for that. And otherwise, thank you so much for watching, and I hope you enjoyed and found this informative. Happy coding, whatever time of day it is for you.